Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome back to this course on circular economy for sustainable buildings, where we are looking at various ways in which we can achieve circular economy through resource conservation, through design of buildings for adaptability, for design of buildings for, in this class we will see design for disassembly. So, what is design for disassembly? So, design for disassembly, also called or also known very popularly as DFD in construction and architecture, is a very sustainable design approach that focuses on creating buildings and structures that you can dismantle easily, and at the end of the life of the building, these materials are disassembled or dismantled to create either new products or new building materials. So, to design for disassembly is actually to create products with the intention of minimizing its value loss at the end of life. So, in construction, this will involve designing a building with consideration for how will it be dismantled and the recovery of the materials at the end of its useful life. This will allow for recovery, reuse or recycling of materials and its components. Thus, it will reduce waste as well as reduce the environmental impact. Therefore, you should always have a clear plan for deconstruction in order to maximize the recovery and reuse of the material at the end of its life. When you start using reversible connections, modular design and traceable materials. So, how can that happen? So, reversible connections can happen if you start using dry connections such as screws or nuts or bolts. Second, important thing is you start to have modular design. When you start to have modular design, for example, if we look at this sketch that we have put, if you look at the roof as comprising of many modules of this particular size, then it is very easy for you to add one more module of this and start expanding the building. Or if you don't want to expand the building, you are actually deconstructing, then it is easy for you to remove a module and make the building smaller. And third is traceable materials. See, this is how each of the subtopic that you are studying now is linked. Traceable materials means building as material banks. So, you can trace where the material is. All of this will contribute to design for disassembly, and this is an important principle of circular economy. Right? And what happens is, because of this, the life cycle of building materials can get prolonged, and it can also promote flexibility for future modifications or relocations. Now, why should we design for disassembly? So, design for disassembly or DFD will help manufacturers to reduce environmental impact. It can maximize resource efficiency. This happens by creating products that can be easily dismantled, reused and recycled. So, how does this happen? First is by minimizing waste. So, what is minimizing waste? It simplifies the recycling and repurposing and therefore reduces landfill contributions. Second is it conserves resources. So, this can actually enable recovery and reuse of materials. Thus, it can cut down on resource extraction. Third is it can save a lot of energy. Disassembly uses less energy compared to the conventional recycling methods. Fourth is it can extend the product's lifespan. This can happen because it can allow for repairs, it can allow for upgrades and part replacements, thus maximizing longevity. And fifth is it can support circular economy goals because it encourages reuse, recycle, all of which is part of sustainable business practices. If you notice, I have been seamlessly jumping back and forth on the concepts of adaptability and disassembly. So, are they related? Definitely yes. So, how are they related? Because both are a step closer to circularity. So, in order to repurpose and remanufacture a product for further use, we need a good recovery system. This is a very, very important part. We need good recovery systems. Also, manufacturers and operators should be able to track and oversee the components which you have dismantled and the materials in one place before taking them further in the disassembly process. So, these two are very important criteria. And if you look at what is adaptable design and adaptive reuse, it means you design for adaptability, you design for flexibility, you design for durability and you design for change. That is design for adaptability. All of this contributes to design for adaptability. Now, if you need to design for disassembly, then what all aspects should you consider? You should consider modularity, under which the building should be designed for disassembly, designed for deconstruction, designed for dismantling, designed for demountability, design out waste, recycling and reuse. And we should be able to design all of this for reuse and recovery, for off-site construction, for optimization of the materials, for waste efficient procurement and deconstruction and flexibility. Only this will contribute to design for disassembly, both of which will contribute to design for disassembly and adaptability, with circular design and reversible design as the primary motive. Now, what is design for deconstruction? Design for deconstruction refers to creating buildings, structures or products that can be dismantled easily for reuse, recycling or repurposing. Their features include first and foremost reversible connections. So, you can use bolts, clips, screws instead of permanent adhesives or welds. Then second is you should be able to conduct material recovery. So, try as far as possible to select materials that can retain value and can be reused without getting degraded. Third is component traceability. You must start implementing the concept of digital passports in order to track materials and components throughout their life cycle. Fourth is circular design thinking. Under this, start prioritizing designs that will facilitate end of life material recovery as well as integrating those again into new projects. This approach is very much necessary for promoting sustainability in construction as well as other industries. If we look at some basic ideas, say like a prototype project that first employs existing architectural parts in second use. So, first is the example of a cyclopean wall prototype where actually you can take blocks which are of different sizes and shapes also, and yet you can place them one on top of the other and start making the wall bigger. Or here in this example you can see that it's a sliced concrete slab. So, you can use these slabs which is actually designed like this. You can use these as modules to place them together, or you can even separate them and have smaller units. So, these are all very random examples and very basic ideas which we are anyways doing, but you need to upscale your thought if you have to start looking at design for disassembly, because it comes with a large challenge packet. Now, design for disassembly of building actually aims to reuse the material by disassembling it at the end of its function, and the two areas where you will have challenges is reuse and recycling of its materials, components along with disassembly of buildings. So, sometimes we can have transformation that can happen easily. For example, if you have a floor plan like this, which is designed like this, you can start expanding it by shifting this A unit slightly and introducing. See, if we look at what this particular building component is comprised of, it comprises of unit 1 and 2 made up of glass and A and B made up of a opaque material. Now, you can disassemble it for various options, like here it is 1, 2, A, B. Now, here if you see scenario B, it is 1A, 2B. Scenario C is going to become A, 1, B, 2 by 2, half of 2, and so on. So, you have flexibility to change the design, which will again get reflected in the spatial planning if you are able to look at a modular scheme. There are further challenges also when you look at design for disassembly, which I am 100% sure the world will eventually overcome. But we need to recognize those challenges so that we can work towards minimizing their impact. So, the uncertainty regarding the quality of the materials and the elements for reuse due to various different suppliers, that can be one challenge. Then next is low demand. So, there can be less demand of such materials and elements because of ignorance of the users or various stakeholders. And third is the customer taste or customer requirement. This is a considerable challenge because there seems to be a negative perception about reused materials. But one day definitely that's going to become a norm and we will overcome that challenge. Then fourth is improvement of the reused materials and elements has to happen, and we should also have methods to assess how the reused material is actually equal to or better than where it was previously used. And then fifth is the design process. So the design process itself is a considerable hindrance because we neglect the end of life phase of the building, and we neglect the fact that the materials can be reused and its components can be reused. Then sixth is the longer time. So the longer time that the disassembly needs compared to the demolition time is another hindrance. So sometimes they may feel it's better to demolish it than start disassembling it, because anyways disassembly is taking more time. But we will again overcome this as we have more technology to start the disassembly. Seventh is the cost. So cost is also another challenge, since design for disassembly is more expensive compared to conventional construction and demolition, which often happens to be cheaper today because we have technology inadequate for demolition, but we don't have that much technology for DFT or design for disassembly. That's why I say that eventually the world will overcome it. Then the next one is lack of involvement. So it is important that all the stakeholders and parties, right from the client to the manufacturer to the designer, they are all involved, and no, they also look at it as a positive challenge. Then there is lack of measuring tool. So a measuring tool which will benefit disassembly and reusability, it is the need of the hour. Such measuring could be developed from successful projects where the data and documents can become accessible through various modes, through publishing or through propaganda and so on. Lack of damage resistant technology. So, the other challenges that appear when designing, say, a concrete building for disassembly is the suitability of dry connections for certain important areas like seismic resistant areas, since the ductability and the dissipation in frames and structures are required to resist the draft and the movement of earthquakes. But we can definitely overcome this with damage resistant technologies. Then there is lack of durable material. So another issue that we should consider is the durability of a material. Say for example concrete. So concrete is a durable material. The use of steel reinforcement will expose the reinforced concrete elements to deterioration because of corrosion. So you need to overcome all these, because when we look at design for disassembly, we are looking at that component or element for a very long time. Now, what are the issues associated with design for disassembly? So, design for disassembly is intended to create buildings to reduce the consumption of new materials and also to reduce the generation of waste in the construction, renovation and repurposing of buildings. In order to increase the life of the building in situ and create buildings that are the stocks of future, and this stock of future is actually the future stock of building materials. So, this enabling of material conservation and buildings that facilitate the recovery of components for the next kind of iteration is intended to provide economic and environmental benefit for all the stakeholders, such as the owner, the occupant, the builder and the community where this building is designed. Now let's look at what are the issues. So first is, generally buildings are difficult to adapt or deconstruct and recover. This because the recovery of materials for reuse and recycling in a cost effective manner is difficult, and some of the reasons or issues with design for disassembly is the increased use of composites and engineered products. So when I say composite, it is mixing of two materials together which actually cannot be separated. So we need to start figuring out how to reuse these materials. Second is, sometimes the cost of labor to deconstruct may be so overwhelming that no, people would start thinking that it is better to demolish it rather than deconstruct it, especially when you start to have too many interlinked or layered products in the building, like say mechanical, optical and things like that. But we can have technology to separate them through, again, various things like having sonic means of separation, trying to understand what is linked where, in which way, just through acoustical waves. So we need a lot of more technological advancement in this. The way connections are used, we have discussed and seen this in greater details. And fourth is loss of craft skill, or rather loss of developing craft skills for deconstruction. Also, the highly speculative nature of most of the buildings. Then the perception meant to have short life, say like exhibition spaces, entertainment avenues and all can have this design for deconstruction. But how viable it is for buildings that have a longer life, it is definitely viable, but it's a challenge to present this to stakeholders. And as I had already mentioned, sometimes the time to deconstruct is much longer than the time and cost for disposal, and that is because we don't have adequate knowledge and systems in place. Of course, structural systems is one of the most important components which I have already discussed at greater length. So if we look at how to conceptualize and have an integrative design for assembly and disassembly framework, I had already told you about how adaptive reuse and modularity, they both contribute together to circular building and reversible design, and also how design for adaptability and disassembly, it is important to consider it in the design and planning process as well as the end of life of the building, which is a birth for another building, and then assessments and strategic value of what you are going to retain for adaptability or disassemble. So design for deconstruction is actually an eco-design method that can enable the assembly and disassembly of buildings to recover building components. We have this concept of design for deconstruction, which is also the design for disassembly, both of which have the same acronym DFT. And an adaptable building can be modified by users to meet their constant needs. The adaptability and deconstruction project will integrate and bring together the configuration of spaces and recovery of material components. So this method is important for us to maintain the building components, parts of the building, materials at the highest level of utility and value. And the basic design principles for design for disassembly is, first is the material choice. It is very important for us to avoid composite materials which is difficult to segregate or separate. So, we should avoid this wherever possible, and also we should use those that are not cast in situ. We should not use welded and bonded joints which use chemical adhesive. So, we should avoid composite material, we should avoid say weldings, welded joints, we should avoid in situ casting, and we should also avoid chemical adhesive bonds which are difficult to identify and also difficult to separate. Also, these can be cost and energy intensive to break down. So, all of this should cost less. So, less cost for any of this is very important. Also, we should start looking at, so this is avoid, but what should you actually do in the material choice? You should look at lightweight materials. So, the materials should be light in weight, and also you should minimize various and different types of material. So, minimize variability of materials. Okay. And then you should also have easy recovery and also easy transport. So, these are the do's for material choices and these are the don'ts for material choices. Then the next is you should start designing for a deconstructible structure. Now, you should start designing for a deconstructible structure. So, designing a simple open span structure which focuses on flexibility and standardized dimensional grids and components will give the building lifespan that is longer. It will also permit ease of deconstruction. So, we should provide adequate tolerances and also minimize the need for destructive demolition. We should start using standardized sizes or modularity in the components because this can ensure better recovery and most important better reuse steadily for a longer period of time. We should give greater consideration especially during the design of facade and also detailing such as cladding systems because they can be really designed for deconstruction and they can save a lot of energy. Then third is accessible and removable connections. So, this is the third one, accessible and removable connections. So, we should use bolts, screws and nailed connections most of the times or most of the places. And what are the don'ts? The don'ts are chemical adhesives, sealants, binders or any jointing that needs specialist tools or specialist equipment. Because of this, it will be easy for us to process the deconstruction and we can save on quantity and quality of material that we can reuse and recycle. And these connections should remain visible and accessible wherever possible so that we can remove them easily whenever we want to disassemble the building. Fourth is design for flexibility and longevity. Now, under this what you need to consider is that the material choice is very important. So, you need to consider under this it is very important for you to create a flexible design. So, your design has to be flexible design which can extend the initial lifespan of a building. So, you should apply open plan principles with interchangeable components, and this can enable alterations to layout and functionality without the need for significant intervention. Also, always specify, because you are looking at longevity, always specify high quality and robust materials. This can provide additional longevity by creating buildings that are designed to last longer, delay the need for repair or replacement and demolition. And then very important is, please make use of technology. So, use digital tools, because these technologies can allow us to track, trace and map the resources more efficiently than ever using any other digital tool. BIM, material passport, all of this can be integrated to track, trace and map our resources. Material passports, they are very important, and their interoperability data sets can describe defined characteristics of materials, products or systems, and this can attribute them to a good value recovery and reuse. Some materials like plastics can be difficult to identify. Try to avoid those materials. Also, the material passport should be embedded in the BIM, and this BIM model can be used to store this information, including from where that resource came. Was that a virgin material, or that itself in this building is a reused material? So, resource origin, then even carbon data can be stored. When was this product first produced? What is the expected lifespan? Like for food, is there an expiry date for that product? For how long it can be used, and for how many cycles can we reuse it? All of this you should try to integrate, and this should be the design principles. How should we design for disassembly if we look at this in toto? So, design for disassembly will involve creating products or structures that can be easily taken apart for reuse, recycling and repurposing. When we follow these simple steps, simplify component connections, don't use adhesives, keep the connections open and visible, select sustainable materials which have a longer life, which are robust, enable easy access to any of the joints, incorporate modularity so that you can increase, decrease the size and so on. Use digital simulation tools. How and why we should use, I discussed it in the previous slide. So, by prioritizing these strategies, all the stakeholders including manufacturers can reduce the waste, streamline recycling and extend product life cycles, which is actually one of the most important criteria or necessity for us in order to practice sustainable architecture through circular economy. With this, I will stop today's class, and we will continue with another topic in the next class. Thank you.